Welcome to online lecture series in organic chemistry. We are discussing the molecular orbital theory for coordination compounds. In earlier video we have seen the assumptions for molecular orbital theory applied to coordination compounds or formation of coordination compounds. Now in this video we are going to discuss the identification of central metal orbitals and their symmetry suitable for the formation of sigma bonds with ligand orbitals. Now in octahedral compounds, altogether 15 orbitals are available for the construction of molecular orbital diagram, and out of these 15 orbitals, 9 orbitals are contributed by metal atom and 6 orbitals are contributed by ligands. So 9 plus 6, it is 15. Now the metal orbitals such as A1G, EG, T1U. So one A1G orbital, two EG orbitals. One A1G means 4s orbital, EG that is d x square minus y square dz square, and T1U means px, py, pz. So these orbitals, these A1G, EG and T1U orbitals are suitable for the sigma bonding because these orbitals are oriented along the axis, and 6 ligand group orbitals, for example summation A, summation x, summation y, summation z, summation x square minus y square and summation z square. These are the 6 ligand group orbitals involved in the formation of bonding and antibonding molecular orbitals towards the formation of coordination compound. So these are the 6 orbitals which are responsible for sigma bond, 6 metal orbitals, that is A1G, EG and T1U, and these ligand group orbitals, that is summation A, summation x, summation y, summation z, summation x square minus y square and summation z square. These are also involved in the process of formation of sigma bond. Now the 6 metal orbitals and corresponding 6 matching ligand group orbitals, we are going to see which are the matching ligand group orbitals corresponding to the 6 metal orbitals. Out of 9 metal orbitals, only we are considering 6 orbitals because remaining 3 metal orbitals, that is T2G orbitals, these are not suitable for the formation of sigma bond. That is, T2G orbitals are suitable for the formation of pi bond and we are not considering T2G orbitals. Okay, now we are going to discuss the metal orbitals and corresponding matching ligand group orbitals with their shape. So first orbital is A1G. This is the metal orbital of the coordination compound A1G or 4s orbital. So it is spherically symmetrical. These are the 3 axes x, y and z. Okay, this is the positive end of x axis, this is negative end of the axis. Similarly, this is positive end of y axis, negative end of y axis. This is positive z axis, this is negative z axis. This also you must know, you know already. Now matching ligand group orbital for this A1G is this one. So here you know there are 6 ligands and ligands are occupying the corner of octahedron. There are 6 corners for octahedron, and in octahedral complex ligands are oriented along the axis x, y and z axis. Now as this slope is positive for A1G, this spherically symmetrical orbital, as this lobe has positive sine wave function, all the lobes of ligand group orbital, they are positive. Okay, so when they approach towards this positive lobe of metal ion, then there is a overlapping, appreciable overlapping. So this is the shape of summation A. So summation A, it is suitable to overlap with A1G. So this summation A, this is equal to 1 by root 6 into sigma x. Actually this lobe has positive sine wave function, therefore this positive sigma x plus, now this plus sign, it is for positive axis, this positive lobe oriented along the positive end of this x-axis, plus sigma negative x. So this is this positive lobe oriented along the negative end of the x-axis. So plus sigma negative x plus sigma y. This is the positive lobe oriented along the positive end of y-axis. So plus sigma y plus sigma negative y. This is for this lobe. Plus sign, this plus sign, it is for positive lobe. Sigma negative y. This lobe is oriented along the negative end of this y-axis. Then plus sigma z for this lobe. It is oriented along this positive end of this z-axis. So this plus sign, it is for positive lobe. Sigma z, it is oriented along the positive lobe of z-axis, plus sigma negative z, plus again it is for positive lobe oriented along the negative lobe of negative end of z-axis. So plus sigma negative z. Okay, next orbital is dz square orbital. In dz square orbital of metal, positive lobes are oriented along the z-axis, and this is the circular lobe, circular negative sine wave function lobes. Now matching ligand group orbital is this one. So these are the positive lobes oriented along the z-axis and negative lobes oriented along the x and y-axis. So here summation z square, this is the summation z square, this is the ligand group orbital which is matching with dz square. So these positive lobes, these can overlap with these positive lobes, and therefore this is the matching ligand group orbital with dz square. So summation z square, it is equal to 1 by 2 into root 3 into 2 sigma z, this is for positive lobe oriented along the positive end of z-axis, plus 2 sigma negative z, this is for positive lobe oriented along the negative end of z-axis. Okay, minus sigma x, so this negative lobe oriented along the positive axis. So sigma x minus sigma negative x. So this is for the negative lobe oriented along the negative end of the axis, x-axis, minus sigma y, this is for this negative lobe, minus sigma minus y, this is for negative lobe oriented along the negative end of the y-axis. Now why this coefficient 2 is here? Because the size of positive lobe, it is double the size of the negative lobes in order to counterbalance the positive and negative wave functions. So these positive lobes are double, and therefore it is multiplied by 2. Then this is the another EG orbital, that is dx square minus y square. Here positive lobes are oriented along the x-axis, negative lobes are oriented along the y-axis. And this is the matching symmetry group orbital, summation x square minus y square. And summation x square minus y square, it is equal to 1 by root 2 into sigma x. This is for positive lobe oriented along the positive end of x-axis, plus sigma minus x. This is for positive lobe oriented along the negative end of the x-axis, minus sigma y. This is for negative lobe oriented along the positive end of y-axis, minus sigma minus y. This is for negative lobe oriented along the negative end of y-axis. So this is about the EG orbitals of metal ion and matching ligand group orbitals, that is summation z square and summation x square minus y square. Then there are 3 T1U orbitals, px, py and pz. This is the px orbital of metal ion. This is the matching ligand group orbital, that is summation x. You know, this positive lobe oriented along the positive end of x-axis, this can align with positive lobe of x-axis of px orbital. So summation x, it is equal to 1 by root 2 into sigma x. The sigma x, it is for positive lobe oriented along the positive end of x-axis, minus sigma minus x. So this minus sign, it is for negative lobe, and sigma minus x, it is oriented along the negative end of x-axis. There is no any lobe along the y-axis and z-axis, and therefore this is summation x. Similarly, this is for this is the another T1U orbital, that is py. Here positive lobe oriented along the positive end of y-axis and negative lobe towards the negative end of y-axis, and matching ligand group orbital is summation y, and here summation y, this is equal to 1 by root 2 into sigma y, because positive lobe oriented along the positive end of y-axis, minus, this is the minus lobe oriented along the negative end, therefore sigma minus y. And the next T1U orbital is pz. Here positive negative lobes, these are oriented along the z-axis, and this is the matching ligand group orbital, that is summation z. So summation z is equal to 1 by root 2. Here positive lobe oriented along the positive side of z-axis, therefore sigma z. Sigma z means plus sigma z. This is nothing but plus sign of sigma. This indicates the positive lobe. Okay, so minus sigma negative z, that is minus negative lobe oriented along the negative end of the z-axis. So this is about the sigma z. So in this way, there are 6 metal orbitals, that is A1G, EG and T1U, responsible for sigma bonding, and there are 6 matching ligand group orbitals, that is summation A, summation x, summation y, summation z, summation z square, summation x square minus y square.